Welcome to the deep dive. Today we're peeling back the layers on something core to Linux, but maybe a bit hidden. It's directory structure.
Right. It seems simple on the surface, maybe, but it's actually this incredibly logical system.
Exactly. It's like the hidden architecture, all defined by the File System Hierarchy Standard, the FHS. Understanding it feels like you're decoding Linux's DNA.
It really does.
Yeah.
And, getting your head around this structure is such a massive shortcut.
How so?
Well, whether you're just starting out, maybe curious, or even if you're trying to figure out a new system, knowing where things live and, crucially, why they're put there,
Hmm.
it just makes everything click.
Ah, okay. It's like having the map before you start the journey.
Precisely. Makes navigating, even troubleshooting, way more intuitive.
Okay, let's unpack this then. Where do we start? The absolute top.
Yep, the root directory, just
Yeah.
that single forward slide.
And literally everything else branches out from there, right? Every single file, every directory.
It all starts at team. It's the ultimate parent directory. And the FHS is what brings the order, the predictability to it all.
So let's walk through some key players at that top level. What are the essentials?
Okay, well, first up, you often encounter bin and spin.
Right, bin and spin. They sound similar.
They do, but there's a key difference. Bin, that's for essential user binaries. Think commands anyone might use, like ls to list files, stp to copy, mv to move. Your everyday tools.
Got it. User commands. So spin.
S for system, essential system binaries. These are more for administration, stuff needed to boot or repair the system. Commands like fesc for checking file systems or reboot.
Ah, okay. So bin for me, spin more for the system or the admin.
Kind of, yeah. That separation is important for security, for system reliability. It's not just random.
Makes sense. Okay, so beyond the commands, the actual doing things,
Yeah.
what about controlling things? Where's the system's control panel?
That would be et cetera. Think of et cetera as the central hub for system-wide configuration files.
So settings for the whole operating system.
Exactly. Network settings, how services start up, security policies. If you need to tweak how the system behaves, chances are you'll be looking in, et cetera. Just CD, et cetera, and you're there.
Okay, et cetera, for system config. Now, what about users? Where do we live on the system?
Good question. That primarily happens in home. Inside home, you'll find a directory for each regular user. So if you're Alex, you'll have home Alex.
My digital home base. Documents, downloads, desktop stuff.
All that, yeah. Your personal space.
Hmm.
But there's a special case, root.
Root. Is that related to the root directory?
Not directly in hierarchy, but in name and purpose. Root is the specific home directory only for the root user.
The super administrator.
Exactly. It's kept separate from home for security. You can usually see the regular user homes just by typing else home.
Right. So home for us, root for the big boss. Now, things get a bit weird, don't they? I'm thinking about directories that aren't really directories, like proc and sys.
Ah, yes. That's where Linux gets really interesting. Proc and sys are, well, they're virtual file systems.
Virtual, meaning they don't actually store files on the disk.
Correct. They're generated on the fly by the kernel. Proc is fascinating. It gives you a window into running processes and kernel information as if they were files.
Like you can just read system info from a file.
Yeah. For example, type cat procuminfo, and boom, you see details about your CTU pulled live from the kernel. No actual file called sepuinfo exists on your hard drive.
Whoa. Okay, that's clever. And sys.
Sys is similar, but it's more focused on the system's hardware devices and kernel modules. It gives you another way to interact with and view the kernel's perspective on the hardware. These virtual file systems are incredibly powerful for diagnostics.
Okay, my mind's slightly blown. So we have commands, config, users, and these live system views. What about stuff that changes all the time, like logs?
That's where var comes in. var for variable data.
Variable, meaning it changes frequently.
Exactly. This is home for things like system log files.
Yeah.
The system's diary, essentially. Also caches, temporary files used by programs, mail spools, anything that's expected to grow or change size often.
So if something goes wrong, varlog is probably a good place to start digging.
Absolutely, or it's often the first place you look. I remember this one time troubleshooting a web server. Varlog saved the day. It's like the system's black box recorder.
Wow. Okay, so just knowing these few key places of bin, spin, etc., home, root, proc, sys, and var, it really gives you a mental map, doesn't it?
It totally does. It unlocks so much understanding. You go from just using the system to actually, grasping its layout.
It makes things less intimidating, I guess. Easier to find stuff, easier to understand error messages, maybe.
Definitely. Troubleshooting becomes way easier. And you start to see how different parts of the system, software and hardware, actually connect. It just provides a deeper insight.
So wrapping this up, what this means for you, the listener, is that this structure, the FHS, isn't just some random layout. It's thought out, logical, designed for clarity and control.
Right. It's a huge part of what makes Linux so stable and, frankly, so secure.
Which leads to maybe a final thought.
Now that you have a sense of where things are and why, think about how that structured approach itself contributes to Linux's strengths, and maybe how could applying that kind of hierarchical logical thinking help organize things in your own work or projects or even just information?
Taking the logic of the file system into everyday life, that's a fascinating idea to ponder.